Hello friends, you must have already recognized this reaction. You've learned a similar kind of reaction earlier, that is single displacement reaction. You've learned the reaction of zinc granules dipped in the solution of sulfuric acid. Now here we have taken iron nails and dipped them in the copper sulfate solution. Now as we all know that iron is more reactive as compared to copper, it displaces copper from the copper sulfate solution, and if you look at the color, this is the normal copper sulfate solution color, and after dipping, after the reaction taking place, the color of copper sulfate fades because the copper gets deposited on the iron nail. Look at this iron nail if you can see. But before doing this activity, we have to make sure that the iron nail is not rusted. And if it is rusted, we first need to remove the rust with the help of a sandpaper. So, here again, what's important? A more reactive element displaces the less reactive element from its solution. Now, look at this. This is the one which we had performed just now, that we dipped the iron nail in the copper sulfate solution. But what if we do opposite of it? That is, we take a copper wire and dip it in the iron sulfate solution. Now as you can see in this test tube, there's no reaction taking place. The copper wire has retained its color. It has not lost its color because iron being more reactive, it will remain bound to the sulfate ion and copper will not be able to displace iron. So this is amazing chemistry. This is a displacement reaction. Here only one ion is getting displaced, so it is known as single displacement reaction. Now let's look at the double displacement reaction. Now what happens over here? Here there's a symbolic reaction shown to you, that's AB. It's a compound, and when it combines with CD, which is another compound, it forms CB and AD. Now how does this happen? Now if you look at this diagram and this diagram, they look similar, but there's one addition of these signs. Now look at these signs very carefully. A is positive, B is negative. Same way, C is positive, D is negative. Now when they react, what's going to happen is always the positive will react with the negative, and thus AD will be formed, as you can see over here. And then CB will be formed. Always the positive ion is written first and then the negative ion. Thus we write AD and CB. That is interchange of groups of atoms or ions. Both the ions get displaced, and that's why it is known as double displacement reaction. Now look at one example of double displacement reaction, that is sodium sulfate reacting with barium chloride. Now if you can see, the negative ion is written in red color so that you can identify it very easily over here. Now barium will react, barium is positively charged, it will react with sulfate ion which is negatively charged, and it will form a precipitate of barium sulfate. Precipitate is something which is heavier and hence settles down in the test tube. And similarly, sodium will combine with chloride. Here sodium is positively charged and chloride is negatively charged. So both the ions have been displaced and hence it is a double displacement reaction. Another common example which you come across is lead nitrate. AQ indicates aqueous, that is, it is in liquid form. So lead nitrate combines with potassium iodide, again it is in liquid form, and what do you get? You get lead iodide. PbI2 is lead iodide, again it is a precipitate. S is written over here in bracket, which indicates it will precipitate down in the test tube along with formation of potassium nitrate. In this way, a double displacement reaction takes place. Hope you're getting me. Let's meet in the next session. Until then, keep learning. Chemistry is very interesting and no more a mystery. Until then, see you.